everybody take out your calculators. We're doing part 2, so the second page. So for the next few equations, all we have to do is plug and chug. So you have to select the correct equation. Again, you don't have to memorize them. They'll be provided to you. So supine, what position is supine? Yeah, because you're on your spine, right? And then seated, Fowler, semi-seated, semi-Fowler. We'll all call that seated. So what do you think is higher? When is your blood pressure higher? When you're laying down or when you're seated? Okay, so let's plug it in. So it's just based on age. So anytime you see years, plug in what is given. So for A, we just do 103.5 minus, and your factor is 0.42 times their age. So 103.5 minus 42 times their age. This is 28.56. And then just simplify that. All right. Now let's do seated. The factor is 104.2 minus 0.27 times 68. Same age. So I got 18 and some change here. About 86 or so. What's mmHg? Very good. So mm is millimeters, Hg is mercury. So we measure barometric pressure either in millimeters of mercury or inches of water. So you're going to have to be able to convert between inches of water and millimeters of mercury for any pressure, barometric.
So in this case, you just rounded up to the nearest high number.
Yeah, I was lazy.
Oh, is that how it's going to be on the actual any type of test or anything like that?
Most likely it's going to be to the nearest millimeter.
So if we round it up like this and don't put in 74.94, is it going to be right or is it going to be wrong?
Follow the directions of the question.
So if it doesn't say to round up or if it just says...
Then yeah, most likely it's going to be to the nearest millimeter. So round appropriately. Yes?
I got it to the 28.56, but where did the 74.94 come?
You just subtract. Yeah, you subtract. So we simplified this first inside the parentheses, and then you still have to subtract, right? That's this subtraction here.
So 103 from 28.56, right?
Yeah.
And then, okay.
Yeah, 103.5 minus 28.56. Yeah, so we'll do whatever is in the parentheses. So we plugged in 68, do what's in the parentheses, and we just simplified. So not too bad. All right, so that's half of the room, so the far half. You guys do supine. And then you guys on this side, you guys do seated real quick.
Seated is 96.91. Well, 97.
Okay. And then for supine, we'll give them a moment. So it's 103.5 minus 0.42 times 27. And the other one is 104.2 minus 0.27 times 27. So you got 97 for seated. What did that far side of the room get for supine? 92? Do we have a second on that one? Let's see, 0.2 times 27 equals minus 103.5. All right, sounds good. So simple plug and chug. So some of these are that easy. Just make sure you pick the correct equation. Map. So your heart contracts and relaxes. So when it's contracting, that is systolic. And when it is relaxed, your heart is in what's called diastole. So that's your diastolic pressure. So the top number is higher, the bottom number is lower. But the amount of time your heart spends in systole and diastole is different. It's going to be about a 1-to-2 ratio. So you contract about, let's say, 1 second. That means you're going to be relaxed, your heart's going to be relaxed for about 2 seconds. So that's what this factor of 2 is here. So that's why you double the diastolic pressure. So here we got our normal baseline, right? 120/80. Let's see what the map is, mean arterial pressure. So you just plug and chug. 120 plus 2 times 80, and you just divide it by 3.
So the 93.
All right, not too bad, right? Let's try high blood pressure. So at 140/90, you are now considered hypertensive. So we got 140 plus 180/3. That's 320/3. So you got about 107. All right. So that's what your arteries feel all the time, relatively. That much pressure. Ooh, this is a healthy person, I guess. 110/70. All right, everyone punch those numbers in. Let's see what you get. I got 150/3. Sorry, 250/3. There you go.
You always divide by 2?
Yeah, because you're going to spend one portion of time in systole and twice as much as that time in diastole for a total of 3. So we're just averaging what your arteries feel all the time. 130/90, 180. I got 310/3, so about 103. All right, not too bad. Plug and chug. So some of this stuff will be that easy. Just pick the correct equation. All right, this is 240/3, so that's a perfect 80, right? Not too bad. Endotracheal tube size for children. And this is an estimation. They only come in half sizes. So your only answers are 2.5, 3, 3.5, 4, 4.5, 5, 5.5. That's it. You only round to the nearest half millimeter. Well, it keeps on going. I'm just saying it's only half sizes.
I think 7.
Yeah, it keeps on going up. So the point here is half sizes. So if you're giving me anything other than a whole number or half of a number, then you didn't round to the nearest half of a millimeter. So we have 2 equations, one by age and one by their height. So let's do A. So for A, we're going to do 13 plus 16/4. Just remember, you got to push equal for the numerator before you continue. 29/4. So let's see, it's right in the middle, right? Divided by 4. So it's right in the middle. So for this one, you would not be incorrect going either way, because it's right dab in the middle. So yeah, I wouldn't, yeah, so the key should give you credit for either or, because that's straight in the middle, 7.25. All right, how old is this kid?
Is
7, yeah, 7 years. So for B, we use 7. 7 plus 16 over 4 is 23 over 4. Another half size. Oh, this is perfectly half size.
6 is 5.5.
No. Yeah. So we can do, yeah, 5.5 or 6. So as time goes, this kid gets bigger and bigger ones. All right, meters to centimeters. What does centi mean to you? How many cent in a dollar? How many years in a century? 100. So your conversion factor is 100. Are we going to multiply or divide by 100? Multiply. So 1 meter, 1.08 meters is going to be how many centimeters? 108. So take their height in centimeters and divide by the constant 20. 108 divided by 20 gives you the nearest. So the nearest size is 5.5. What is this? 5 feet, no, 3 feet, 5 inches. How many centimeters is that?
65.
So let's see, how many inches is that? 41. So we got 3 and 5/12, right? That's what it means. How many inches in a foot? 12. So 3 feet 5 inches is this mixed fraction. So you take the 3 times 5. No, sorry, 3 times 12 plus 5. 3 times 12 is 36. Plus 5 is 41 inches. But we usually don't write the 12. So now that we got 41 inches, how do I go to centimeters? Do I multiply or divide by? Multiply. So 41 times 2.54 gives us how many centimeters? about 104, right? About 104. So for D, we got to convert inches to centimeters, divide by 20. The closest size would be 5. So we got 5.4, 5.2 or something. So only half sizes available. Cardiac output is over 1 minute. Very important. Anytime you hear the word output, that's over 1 minute. If you just hear the word stroke, that is just one beat, right? So if you take the volume of one beat, right, how many beats per minute your heart's beating, that's going to be the volume of blood your heart is moving. So for this first example, every heartbeat, their heart moves 75 mLs of blood. So that's every beat. So they do 75 mLs per beat. Over a minute, there's 70 beats. So what is the volume in liters, right? So once you do 75 mLs times 70, what do you get for that?
It's going to be 5.25.
5250 mLs. There you go. There you go. So you're in mLs. So very important, you're in mLs. But they want the answer in liters, right? So just change it to liters. So what does milli mean? We know what kilo means. Everyone likes that one from yesterday. The base unit in the metric system has a value of 1. Milli means 1/1000th, and micro means 1/1 millionth. So if we have a liter, then we'll have a milliliter, and then we'll have a microliter. Kiloliter. All right, let's do the second one. 60 times 82 divided by 1,000. There you go. So don't forget, just take a note of your units. Lastly, right, a couple more things. Cardiac index, you're going to have to use body surface area. Do you recall the equation for body surface area?
It's 4 times the kilograms plus 4 over the, yeah.
So once you use them enough, you're going to start memorizing them. But I'll always give you the reference on the midterm. All right, so plug and chug this time. All you do is take the cardiac output, and anytime you hear output, what is that over? 1 minute. So you take that volume of blood that your heart can pump over a minute and divide it by the patient's body surface area. So for this first one, we'll call it A. Everything is given to us in the units we want. Right? We got liters per minute, and we got meters squared. So that's all the units we want. We're happy. All you got to do is divide. Liters divided by body surface area.
So 3.57.
Yeah, that's it. 3.57. Now for B, we have to calculate body surface area. So 4 times 75 plus 7 divided by 75 plus 90. So we got 307 over 165. That's what? 1 point? No, this is times. A dot means multiply. Okay, I'll put an X, sorry.
No. It's 4.5.
Oh, 4.5 liters. Okay. Oh yeah, this is, no, the 4.5 doesn't go here. I want kilograms here. Your 4.5 is not here yet. We haven't done body surface area yet. This is BSA. We still have to do BSA. It's not given to us. We're given kilograms, not meters squared. So you have to solve for meters squared first. So you guys are jumping the gun there, trying to confuse me. That'll put you in timeout or in the boxing ring. You pick. You sure? You Western boxing? You lean forward. I'm gonna beat the shit out of you. I'm gonna kick the heck out of it. You're dead. Right? So if you're Western boxing, you only got 2 weapons. If you're gonna really fight, I got 8 limbs. And I ain't got you at the foundation. You sure? Why? Because the foundation. That's all you'll know. All right. Are you from the Netherlands?
And Norwegian.
Norwegian. That is Scandinavian. So if you're from Holland, then yeah, I would suspect different. They have a wider tradition of kickboxing. In the Netherlands, I'm not quite sure. My cousin's in Norway. All right, so for this one, now you take the liters, 4.5, and you divide it by the body surface area. All right, so now 4.5 comes into play. 4.5 divided by 1.86.
2.42.
Yep. So 2.42. All right, so sometimes you'll have to find body surface area. Sometimes it's given to you. Sometimes cardiac output is given to you. Sometimes it's not. Yeah.
What was the numbers that you used to calculate the BSA?
Body surface area? All right, so the equation for body surface area, 4 times the kilogram plus 7 over the kilograms plus 90. So refer to page 1 of the handout, and it's the third slide. That's the equation right there. 4 times the kilograms plus 7 over kilograms plus 90. So you have to solve for the body surface area if it's not given. All right, for the first one, we are not given cardiac output, but that is easy to solve. We did that in the previous. Take the mLs times the beats per minute, but remember that gives you mLs, we want liters. So 4680, this is 4.68. So take the 4.68 liters that you solved for the cardiac output, and all you do is divide by body surface area.
It's the same formula as cardiac index.
This is cardiac output. This is CO. So cardiac output equals stroke volume times the heart rate, beats per minute. That'll give you mLs, just change it to liters. So the first thing we have to find is CO, and then CO divided by body surface area will give you cardiac index. So we solve this as 4.68 liters per minute, and the body surface area is given to us. All you do is solve the quotient, and the patient's on the way to being dosed correctly. So they have an index of 2.75. All right, since this is the last thing, I'm going to give you guys a few moments to solve this one. You will need to first solve cardiac output. You will then need to solve for body surface area. Once you get those, bring them together, CO over BSA.
Is it 2.6?
Is it? I don't know. 2.6 maybe? Maybe? Dun dun dun. So everyone, give it a try. All right, what'd you guys get?
2.6. I left off the 8.
Okay, not bad. All right, so first step, you got to find cardiac output. So to find cardiac output, we take the stroke volume multiplied by the heart rate, beats per minute. That gives our answer in mLs, but we have to convert to liters. So cardiac output is 5.12 liters per minute. Next, we need to solve for body surface area. So BSA. So we were given pounds. We got to divide by 2.2 to get kilogram. The equation requires kilogram. So that's about 79 kilos. We plug it into our BSA equation, and that comes out to about 1.91 meters squared. BSA, CO. So to find cardiac index, you're going to take cardiac output, which is 5.12 liters per minute, divided by the body surface area, which is 1.91. So you got all the little parts that we've broken down, figured out how to do, and then you might have to put it all together in something you haven't seen before in order to solve it. So your base, apply it to something you know how to do, and then once you apply it to something that you haven't seen before, you're going to have to be forced to use what you've learned. So that's Bloom's taxonomy. And you guys get to use your calculators. Say thank you.
Does every quiz, final, all that stuff, calculators?
Only for this class.
Nice.
After this class, everything you have to do in RT is by hand. Your exam, your certification, everything else.